So hello everyone and welcome back to SWEcodes. So this video is in continuation to binary search series. So we have done pretty much easy questions on the lead code. Now let's try to solve some medium questions on the lead code. So I have a new problem, that is find the minimum in the rotated sorted array. So this is a medium problem and you can see the tags. It has been asked to the many good companies, the product based companies. So let's try to give a read to this question. So we are given an array of length n. Yeah, it is sorted in ascending order. Yeah, but with a twist that it is rotated between 1 and n times. So what does this rotation means? For example, this is the original sorted array, but if we rotate it four times, like if you rotate it four times, like 0 would be rotated to the four times, 1 2 3 4, then 0 would be here. You can see 0 is now here. Now the array becomes 0 1 2 and all the elements greater than 2 will come to the beginning, 4 5 6 7. So it's kind of rotated in that way. And if you rotate it 7 times, n times, that is you will get your original array back. So what we are given, like we are given the sorted rotated array of unique elements, and we need to find the minimum element of this array. So if it was only sorted, then it was very easy, like the first element would have been the minimum element. But with a twist, like it is rotated and we don't know how much it is rotated, we need to find the minimum element. So there is a twist, and we will say how we can apply binary search to this problem. So let's try to analyze it. So I'll just quickly share the input. Okay, let's try to analyze it. So we have something like 4 5 6 7 0 1 2 3. So you see, this is the array which is sorted but rotated how many times? If you'll see, original array would be something like 0 1 2 3 4 5 6 7, and we know that array elements are unique or distinct elements. So if you will see carefully, 0 would have been here, but now 0 is here. So how many times it is rotated? 1 2 3 4. So this array is rotated 4 times. The number of rotation is 4. The array is rotated 4 times. What you need to find? You need to find the minimum element. We need to find the minimum element. So with our technique, what we applied is, like we define a condition in array such that we'll have the false values, series of false values, then we'll have the series of true values. That means from where you want to start the true value, because with our technique we will always get the first true value. So since we want to find the minimum, so we can assume that we should start true values from the minimum element. So this should be our condition, and all this should be false. So f of x should be something like this, but here we don't know how to write the condition. We know that this could be the conditions array, but you don't know the condition. So here we just have to bother something about condition. So we'll just check how we can write a condition. So if you can assume something similarities between these element and something similarity between these element, then it would be very easy to identify the condition. I'll just share you how. Suppose your array starts from here, like 0 1 2 3, and this is the last element in this array. This is the last element in array. But we know that if mid element starts something in middle or in anywhere in between the array element, then after the last element will have some elements that comes to the beginning, and these all elements must be greater than this, because our minimum starts from here. We go to 1, we go to 2, we go to 3, but 3 is the last element in this array currently. But we know that since it is sorted and rotated, and since it contains unique element, then there are elements greater than 3 left, and they should come to the beginning. So if you will see carefully, all the elements greater than 3 will come to beginning before this minimum element. So if you can define a similar properties to all these elements, it is very simple, like all these elements are greater than 3, and all these elements from minimum to this 3 will be less than equals to 3. How? Let's define this condition. So if you will see carefully, after 3 we'll have 4 5 6 7. That means since it is sorted already but it is rotated, and since we have last element as 3, then these elements before the minimum element must be greater than 3. These element before the minimum element must be greater than 3. So this 4 is greater than 3, this 5 is also greater than 3, this 6 is also greater than 3, and this 7 is also greater than 3. Similarly, if you define similar properties for the minimum elements to the last element, then all these elements, if you will see, this part is already sorted in ascending order. So all these elements are less than equals to the 3, less than equals to 3. All these elements are less than equals to 3. All these elements are less than equals to 3. So if I'll erase everything, I'll write a simple condition such that all these elements satisfy property less than equals to 3, and all these elements satisfy property greater than 3. And how we get 3? We get 3 at the last element of array. That means all these elements are greater than a of I, and all these elements are less than equals to a of I. So it's pretty much clear, like our f of x is defined as, we want to define for the true values and we want to find the first true value. So what is the condition for true? X should be less than equals to a of I. This is our condition. This is our condition, because if x is greater than a of I, and we know that it's a sorted but rotated, and if we have elements here that are greater than this, that means minimum is somewhere in between the array elements. Minimum element is somewhere in between the array elements. So all these elements are greater than the high value. All these elements are greater than the high value. Greater than the high value, like array of I. Yeah. So it's a pretty basic understanding. If you will try to define a conditions array such that it's sorted, then you will get to know the logic behind this. So let's quickly try to implement it. How will implement it? I already have pasted the template. Of our basic binary search using a different perspective. You just need to modify the condition. So what was our condition? Our condition was nums of mid. For the true values, our condition is less than equals to nums of high. So what you need to return after this while loop, your low will be equals to high, and it will like point to the first true value. So that first true value is the minimum element. So we just need to return that. And it's not nums, it's a. Let's try to submit it. Let's try to run it first. Yeah. Yeah, it's accepted. Let's try to submit it. Yeah, it's accepted. So you see, you just need to define a condition for your problem statement and everything would be fine. You just need to find the first true value. So hope you like this video and hope you love this concept, and if you love this concept, please do like, share and subscribe the channel, and please don't forget to put your valuable feedbacks in the comments, and see you in the next video.